Hello everybody, this is Mr. Carey coming back to you with another GoMath 4th grade lesson, and we are past the Chapter 4 mid-chapter checkpoint, so congratulations on that. And now we're moving on to lesson 4.7, and this is going to be division using repeated subtraction. Now I want you to, everyone's looking at the boxes on the right, my 72 boxes. Go ahead and ignore them for now because we're going to touch those in a minute. But first, probably one of the questions people have is, what do you mean division using subtraction? I mean, how is subtraction even like division? Well, to answer that, what I want to do is I have two things up here. And one of them says division is the opposite of blank, and subtraction is the opposite of blank. So if I were to say this, right, division is the opposite of, what would you say? Yeah, I would say multiplication as well. Let's go ahead and type that in a different color. There you go. Yeah, multiplication, good. And then subtraction is the opposite of what? Of addition. All right, let's move that over there. Good. Well, that right there gets us started. And to do that, I'm going to do a little multiplication and addition first. So many of us, when we were in chapter 3, we got used to multiplying just using repeated addition, which is, you can absolutely do that, right? If I wanted to do, let's do a quick problem here using multiplication. Let's go ahead and do 6 times 4, all right? 6 times 4. Okay, which we know are facts, we know that is 24. Now, if I didn't, and I was just starting off with addition or multiplication, I could do this. 6 plus 6. I put a bunch of plus signs, you don't have to. So 6 times 4 is nothing more than 6 plus 6 plus 6 plus 6, or adding 6 to itself 4 times, which gives me 24. Well, what's cool is we can use this principle of repeated addition and multiplication, and we can turn it on it. We can turn it around and do repeated subtraction for division, which is pretty cool. You'll find that it's not a very efficient way. It's not something I would do super hard long division problems with, but it's a great tool for showing you how division works. How, you know, if I get confused and I forget how to set up my problems, you know, if I forget how to set it up, like, you know, if I forget to do this and I get kind of confused, like, if you don't understand that, right, repeated subtraction is a great way to kind of get you out of that, get you unstuck, right? So let's go ahead and start. And now we're going to go ahead and start off with our 72 little boxes over there, provided I can get rid of my subtraction is the opposite of, that's fine. If I can't, whatever. Okay, so let's look at, I really don't want to delete that whole thing. Let's just delete that. Perfect. Okay, so perfect. There we go. Now we're in business. Okay, so the problem, and if you have your math books with you, sorry for that, technical difficulties. So if you turn to page 169 in chapter 4, we're going to learn about John, right? And John, I'll type this here, John is building a brick oven, a backyard pizza oven, which that's right up my alley. Building a backyard pizza oven. Awesome. With an arch opening. You don't really need the arch opening, but if you're into that, cool. John is pretty cool for doing that. So he has 72 bricks. And look, we have 72 bricks to our right here. He has 72 bricks. He will place 6 bricks at a time as he builds the oven. Now, why? I don't know. It could be something to do with they're too heavy. It could be, he wants to measure them. It doesn't really matter why. He's going to place 6 bricks at a time as he builds them. So if he arranges the bricks in piles of 6, how many piles will he have? And this is a good question. Many of us talk about, real life math, and am I ever going to use this? I'm never going to use math. This is good because I don't know. I've never built a backyard pizza oven, but I do. I've worked with bricks before, and it is super helpful to have your bricks organized and arranged. And you want to see if you can place 6 bricks. Are you going to have any left over? So this is really cool. And we're going to do repeated subtraction here. So we're going to begin, right? Let's write down what our problem is. Now that we're not going to solve it like we usually do. We have 72 bricks, and we want to have groups of 6. Okay? So how many groups of 6 or piles of 6 will I have? Well, that looks like 72 bricks divided by 6. Gives me what? And that's what it is, right? I have 72 bricks, and I want to make 6 piles, right? I want to make 6 piles, 6 groups, whatever. How many bricks will be in each pile? Remember, that's what we're asking. So here's my divisor. There's my dividend. And here's my quotient. Some of us are still getting used to quotient. Again, answer to a division problem. Okay, so we're not going to set it up like 72 divided by 6. At least not right now, we're not. So let's check this out. Let's get rid of that. So now we are going to set this up just using subtraction, which is really cool. And as I do the subtraction, I'm going to take off different little bricks to the right. So let's start off with how many bricks do we have? We have 72 bricks. Okay, so what we're going to do is we take our divisor, right, which is right there, piles of 6. That's our divisor. And we're just going to start subtracting 6 until we get down to 0 or a number less than 6. So, but the key is we have to keep track of how many times we subtract. So let's subtract the first time. 72 minus 6 equals 66. Now I'm going to put here, I'm going to put 1 time. And that's just so I know how many times I'm subtracting. So there is 1 time, and you see I crossed one out. There's 1 group. All right, and let's go back. 66 minus 6 equals 60. And I'm going to put 2. And then we're going to keep going. Again, this gets a little long. 60 minus 6 equals 54. And there's 3. Perfect. And then we're just going to keep going until we get down to 0 or a number less than 6. 54 minus 6, 48. Good. As you can see, I'm keeping track of how many times I'm subtracting from 72 using my divisor, right? My divisor is 6. So 48, we're going to go, and if we keep going, let's keep going. Yeah, let's keep going. Why not? You can see this all the way through. 48 minus 6, and excuse my handwriting, 48 minus 6 equals 42. Good. 5. Good. And then we have 42 minus 6 equals 36. Oh, we're getting there. I may have to erase some of these too. 36 minus 6 gives me 30. Now, some of you in my class are probably like, oh, Mr. Carey, this just takes forever. Well, yes, that's why this isn't a terribly efficient way to do division. Oh, I forgot to. 1 time, 2 times, 3 times, 4 times, 5 times, 6 times, 7 times. It's not a terribly efficient way to do division, but it's to show you, that we can do this. 30 minus 6 equals 24, and that's going to be number 8. Cool. And let's do 24 minus 6. Anybody? Good. 18. And that's number 9. And then, sorry, I'm going to have to erase over here. No, I don't want to erase all that. I just want to erase this. So we're going to erase this. We're already at 9, just because I'm running out of room. And I didn't really plan my writing out very well. So 18 minus 6 gives me 12. Good, and that's number 10. And look, we're almost there. 12 minus 6 equals 6. That's number 11. And we have 6, so 6 minus 6 gives me 0. And that gives me 12. And there's 9, 10, 11, 12. So how many piles will he, well, how many times have we subtracted 6 from 72? All right, the answer is 12. We subtracted 6 12 times. Cool. So there are going to be 12 piles of bricks. I mean, that's your answer, right? Because imagine me as John, I've got my pile of bricks over here. Now, of course, I conveniently group them into 6 for you. But imagine John has his piles of 6 here, or his piles of 72, right? And he needs to separate them out. So imagine he's doing this, right? He's not going to divide. He's not going to have any scratch paper with him. He's just going to have his bricks. So imagine him taking, which I'm going to do here, imagine him taking this and taking his groups, oops, I just made a copy, is not what I wanted to do, but he's taking his groups and he's moving them, right? Which is pretty cool. He's going to take his bricks and he's going to move his bricks. And then he's going to group them into piles of 6. Well, that's all he's doing. He's got 72 bricks. He takes 6 at a time and takes it away and moves them into separate piles. So then he's left with 12 piles of 6. Now, we can check this to make sure we're not, we didn't get too far off here. But let's test it out. So if we want to check, remember, division is the opposite of multiplication. Multiplication is the opposite of division. So let's use multiplication. Let's do, we said 12 times, right? Okay, 12 times 6. Let's check our answer. So 2 times 6 is, good, 12. And we have to regroup, put our 10s over here. 1 times 6 is 6. 6 plus 1 is 7. And look at that, it works. Which again, this is a fantastic way. Use multiplication and division to check your answers. So our answer, John, will have 12. He will have piles of 6, and each, there are going to be 12 piles of 6. So he's good. 12 piles of 6. All right. Now, if you don't want to use, the subtraction, or you don't want to do the minus, and you don't want to have the, with the drawing the boxes, you don't want to do all that, that's fine. We don't have to do that. Let's use something I like, which I've gotten very used to doing. It's called a number line. And number lines are really cool because it's another way to visually see where you're not drawing out boxes, which can get kind of tedious. So let's draw out a line. And there's a line. All right. Let's move our line right here. All right. We're going to do... we'll do something without a remainder, something that just divides evenly, even though remainders would work. We'll do one with divide evenly, and then we'll do one with a remainder. Okay, so for those that are keeping track, we're on page, oh, where'd my line go? We're on page 170. So we're going to do 52 divided by 4. I don't have a fancy word problem for that. It could be, I now have 52 bricks, and I want piles of 4. How many piles will I have? It's fine, we'll do that. Mr. Carey's going to be making a backyard oven too. Probably won't be as good as John's. So I've got 52, and we're going to divide by 4. So again, some key terms here. My dividend, my divisor, and my quotient. Good. So 52 divided by 4. So what we can do is we can just use the number line to do repeated subtraction, right? It's the same thing. You're just not setting it up like a subtraction problem and doing the minuses and that. You can do that if you want. So let's get started on that. And I'm going to do this in red just so we can see. So I'm going to start off at 52. And I'm going to go all the way down to 0. Oh, sorry, I forgot to put my little arrows on there. Okay, perfect. There's my number line. So if I'm starting at 52 and I'm going to use repeated subtraction, all that's going to look like is this, 52 minus 4. And I'm going to do that until I get down to 0 or something less than 4, and I can't subtract from 4 anymore. So we're going to make our little jumps. So 52, and we just have to count up our jumps. So I'm going to go like this, 52 minus 4, boom, 48. Put a little doot, and we go, boom, there's my other jump. 48, 44, boom, 40, boom. And this is just me going down my number line. Now I don't have the traditional number line with the, all the lines. I'm just kind of going how I know the number line is. But you can draw a number line just like this, 36. Or you can, if you like using them, I have some I can print out. You can absolutely use this if you want to do repeated subtraction using number lines. So all I'm doing is just subtracting by 4 every time. And this is just counting by 4 but doing it backwards. And this is where, when Mr. Carey talks about fluency and really understanding math patterns, like this really comes in handy. Understanding 4s, understanding your multiples of 4. Let's do 16, making our little jumps, 12, boom, 8, 4, and yes, I know that's a big jump to 0. Clearly that's not a good number line, but you get the point of what I'm doing. So now let's count up how many times we jumped. Now I would normally count up as I'm doing it, but I wanted to make sure I was really focusing on not having too much space or enough space. But so this is 1 time, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So how many equal groups of 4 did you subtract? Well, there it is right there. We subtracted 13 times. We subtracted 4 from 52 13 times. So 52 divided by 4 is 13. Again, this is, subtraction and division you can use. You just have to, subtraction with division, it just takes a long time. You have to do it like this. But it's a very useful way where, again, if you get stuck, just start subtracting, right? And let's use one. So we've had stuff without remainders, which is good. I don't really like to mess around with remainders, but ultimately we're going to have to mess around with remainders. So let's go ahead and do that. We're going to use 32 divided by 3. Now I know that's not going to divide evenly. How do I know? I kind of know, because I can look at the multiple of 3's and I know 32 is not a multiple of 3, or 3 is not a multiple of 32. But we're going to check this out. We're going to see what this looks like. So there's my number line. I will try and not mess it up this time. Let's put my 0, and then we're starting off at 32. So our question is, what is 32 divided by 3? And if you want me to come up with a fancy word problem, I can. Mr. Carey he went Halloween trick-or-treating, even though he's 39 years old, and he got 32 pieces of candy, and he wants to arrange them in groups of 3. How many groups of 3 will Mr. Carey have of his Halloween candy? It's actually not mine, it's actually my son's, both my kids. So we are going to use repeated subtraction, 32 divided by 3. So we're just going to subtract 3 from 32 as many times as we can until we get down to 0 or until we get down to something that is less than 3 we can't subtract from, right? And that's going to be cool because that's going to be a remainder. But let's start off, and I'm going to use red again, and I will try and space this out better. So 32 minus 3 is 29. Good. 29 minus 3. And then we're going to go 26. Boom. Keep going. We have 23. We're just counting by 3s backwards. 20. Sound effects are, you don't have to do them. I like to do them though. 17, then 14. There we go. And then, yeah, I might even space this out well. And then we go to 8. Yeah, kind of. Then we go to 5. Good. And then we go to 2. And then I'm going to put my little tick marks there. 1, 2. Uh-oh. Well, we're kind of stuck here, right? And let's count how many times we've subtracted. We've subtracted once, twice, 3 times, 4 times, 5 times, 6 times, 7, 8, 9, 10. Well, we've been able to subtract it 10 times, but we have some left over, right? What's my difference between 0 and 2? 2 minus 0 is what? It's 2. So guess what? That is going to be my remainder. I can count back from 32 by 3s 10 times until I reach the number 2. I can't count by 3s anymore because then that would give me something less than 0, and that's not what I'm looking for. So my remainder is going to be 2. So the answer to this, I have subtracted 32, I've subtracted 3 from 32 10 times, and I have 2 left over. So that is repeated subtraction. Now there's a couple other, you don't always have to, one of the questions is probably going to be, Mr. Carey, like what would happen, right, if I have like a really big number, right? Let's say, I don't know, let's do 240 divided by 60. Many of us don't know how to count by 60s. I could probably think about it. It's not something I'm born with. But what's kind of cool is you can just count back. I remember when we do these big numbers, 240, 2040, and 2400, right? If you want, just ignore your zeros, right? You know they're there. Can you count back by 6s? Sure you can. And then that looks a whole lot friendlier. So counting back, and let's, why don't we just take a look of what that looks like. We'll do that real quick. So here's and I'll try and draw my straight number line again. Here we go. Boom, right? Okay, and we're going to start off at 240. And here we go. We'll start off at 240, arrow. Now what's cool, I'm going to start with 240, and I'm going to count back by 60s, but I'm just imagining that I'm just doing by 6s, just because it's a little easier, right? And you'll see what a big jump it is. So 240 minus 60, or 24 minus 6, is what? 18. Well, that would be 180. And then 180 minus 60 is what? Or 18 minus 6 is 12, or 120. And then let's do another jump. 120 minus 60 is 60. And then, I've got a huge jump because drawing number lines and spacing stuff out is not my thing. But you see where I'm going. 60. And then how many times have I subtracted? Once, twice, 3 times, and 4 times. So when you have really big numbers like that, that's something you can do is, again, these zeros. We love zeros, but understand that you can kind of take them off and put them back on. Remember our basic fact, right? Basic fact, 6 divided by 24. Anyway, I don't need to discuss repeated subtraction anymore. I think we understand it. And again, it's just a good way to kind of visualize how division works. So many of us have already kind of made that connection, but for the ones that didn't, this may be a good aha moment of, oh, that's what division is. So for now, please leave any questions in the comments below. If you want, check out my previous videos, my lesson 4.6. 4.6 was a pretty good one. That was my using the distributive property. And it's kind of probably one of the first times I've really done distributive property with division. And I kind of like it, only because it's very much like perimeter and area. And for, those of us that, well, all of us are going to move on to 5th grade. But once you start messing around with perimeter and area, once you get familiar with having the area but not the perimeter, or having a side and not having the side, like once you get comfortable with that, it gets a whole lot easier. And so it's really cool to use that distributive property for division. The next lesson, 4.8. If you thought you were done with partial products, guess what? We get to do partial quotients. So for now, this is Mr. Carey signing off. Again, leave any questions, comments, concerns in the comment section, and I will see you next time. See you.